Hello class. Today let us learn what is divergence of a vector. Divergence of a vector. Let us take a vector. Let u be a vector. Okay, I want divergence of u denoted by div of u or del dot u. Del dot u is nothing but is a scalar. We all know, right? We all know, no? Yes. That's nothing but dou u I by dou xi. So divergence of u is nothing but dou u I by dou xi. As we know in our previous classes, we have learned this in our degree classes. And that is nothing but there is a partial differentiation with respect to xi, so comma notation can be used. So ui comma I, and ui comma I is nothing but divergence of a vector is nothing but a scalar. What is vector? Vector is a tensor of order 1. When you apply divergence to it, what is happening? It is becoming a scalar. That means what? It is like a demotion. The order is getting reduced by 1. Fine. Now, let us take up divergence of a tensor. Let us take a second order tensor. Let A be a second order tensor with the components Aij. Then, the divergence of the tensor A is a first order tensor or a vector denoted by div A or del dot A. Del dot A is a vector, so only one free suffix I, and that is equal to dou Aij by dou xj. So there is differentiation here, so comma notation can be used. So that is equal to Aij comma j. J is dummy here, so only one free suffix. So definitely this is a vector tensor of order 1. Right? And we can easily prove. Now this is assignment for you people to show that this Aij comma j is a first order tensor. In other words, Aij comma j is a vector. That's about divergence. So divergence is like a demotion. Right? In the last class we learned gradients. Applying gradient is like a promotion. The order gets increased by 1. In the case of divergence, the order is getting decreased by 1. Right? Now let us take up the curl of a vector. Now coming to curl. Okay, now curl of a vector. So what is curl of a vector? Curl of a vector. Let us take a vector u, right, with the components ui. Curl u, right? We all know this by our, in our previous classes we have learned this. So curl u is nothing but del cross u. And del cross u is again a vector. See, curl of a vector is again a vector. The order remains the same. Whenever you apply curl, the order will not change. Fine. So curl u is again a vector. So only one free suffix I. So we have determinant ijk, dou x1, dou x2, dou x3, u1, u2, u3, the third row. And how do you expand this? That is nothing but I'm writing only the first, I component. So I component I want, that is equal to dou u3 by dou x2 minus dou u2 by dou x3. And how do you write this now? Using comma notation, you can write this as u3 comma 2. You have u3 with respect to dou x2, no? So u3 comma 2. Then minus as it is. Then we have, u2 with respect to x3. So comma notation you can use again here. So it is u2 comma 3. Right? That is equal to, now we'll use permutation symbol. Right? So that is equal to, I can write 1 into u3 comma 2 minus, okay, 1 into u2 3 comma 2 comma 3. Right? Now this 1 we write it as epsilon 1 2 3. 1 we'll write it as epsilon 1 2 3. Okay, so let me take 1. I write 1 there. 2 and 3. So this is our cyclic order. Okay, now epsilon 1 3 2. See, if 1, 2, 3 is cyclic, right? What about 1, 3, 2? So here have 1, 3, 2. So take 1, 3, 2. So 1, 3, 2 is becoming what? The reverse, right? So it is minus, and there is one already minus here. So 1 minus here, it will become plus. Okay, guys. So that is equal to what? Epsilon 1, 2, 3, u 3, comma 2. Let me rewrite here. So epsilon 1, 2, 3, u 3, comma 2 plus y plus, understood? Because there is one more minus sign coming from epsilon 1, 3, 2, and there is one minus sign above, so it will become plus. So epsilon 1, 3, 2, u 2, comma 3. Right? This is the first component we have written. Right? Now, that is equal to, now we'll generalize this. So epsilon ijk, epsilon ijk, right? I'm writing only the first term. I'm generalizing, right? So just watch this. Watch the first term. First term is this. Let us watch this. So epsilon. So in the place of 1, I've taken I here, right? So next I have 2, 3. So for u, it is reversed. 3, comma 2. So here what should come now? It is k, comma j. So therefore, curl u. Curl u, what component? Curl u, right? What component? I component is nothing but epsilon ijk, epsilon ijk, u, k, comma j. Right? So curl u is again a vector. When you apply curl, the order remains the same. The order of the tensor remains the same. Okay, so we saw curl of a vector. Now we shall go to curl of a tensor. Now what is curl of a tensor? Let us take a tensor. Let A be a second order tensor. Okay, with the components aij. With the components aij. Okay. What is curl A? Curl A denoted by del cross A. 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 So del cross A is nothing but second order tensor. If A is a second order tensor, curl of A is also a second order tensor. Curl, when you apply curl, the order will not change. So curl of A, second order tensor, no. So how many free suffixes? 2 free suffixes should come. So ij. That is equal to, now this defined as epsilon imn. Look at ij, where ij are coming. And let me rewrite here. So it is curl A. A is a second order tensor. Curl of A is also a second order tensor. So it will have 2 free suffixes. That is equal to epsilon, right? Epsilon imn. So I, m is dummy, n is also dummy. So this I put I here. Okay, then dou ajn by dou x m. Fine. So here is I and here is j. M and n both are dummy. If I have mn for epsilon, it is the reverse here. First n, then m. Fine. So let me rewrite that. That is equal to epsilon imn, right? Dou a j n by dou x, or that is equal to epsilon imn as it is. I can use comma notation. So jn comma m. Comma n. And we can easily prove that this is what? We can easily prove that curl of a tensor of order 2 is again of order 2. That's again an assignment for you people. Okay. Now we shall go to the next definition. The next definition is cofactor of a tensor. Okay. So we shall stop here. Now in the next class, we shall go to cofactor of a tensor and one problem based on this. Thank you.